It started with the Department of Energy wanted to have a look at what was going on primarily along the eastern, not the East Coast, but eastern U.S. So there was a site at Whiteface Mountain, New York, Ithaca, New York, Virginia. Eventually there was also a site in Delaware, Lewis, Delaware, Miami University in Ohio, and eventually here at the Illinois State Water Survey. And it was research primarily. Nobody knew anything about what was going on with acid rain at that time. There had been a big study, Metromix, down in St. Louis a few years before, where this idea came up with the people that were working on it, but they didn't know what was going on. So AirMon was designed to keep the samples at a constant temperature in the summer. So it was a cooled collector, and they were collected through funnels and into bottles, and the bottles were shipped intact to Battelle Pacific Northwest Labs out in Richland, Washington, where we analyzed them for the same thing that's being analyzed now for NADP and for AirMon, which was calcium, magnesium, sodium, potassium, ammonium, chloride, nitrate, sulfate, pH, and conductivity. But we also had a small vial that was sampled that had tetrachloromercury put into it to preserve the SO2 in the sample, and we analyzed separately for sulfite rather than just the sulfate after everything converted over. That was the beginning, and that started a couple of years before NADP did, which was in 1978. And the same people were still working and thinking about it, and they decided that instead of just having this research project, they needed another program that would work and eventually cover the entire country, and so they started NADP. MAPS continued on for, let's see, it was in 76, for at least another 15 years, at which time there were lots of issues because it had been two different labs. I had moved here, and they were having financial problems with some of the sites, and they switched over from the old MAPS network to most of those sites becoming part of AirMon, which was the Atmospheric Integrated Research Monitoring Network. Quality assurance is basically what it says. It assures the users of the data that the quality is not perfect. You're never saying that this number is this number 100%. What you do is you define parameters around any given number and say, we know this number is right within plus or minus some known analytical measurement that you can prove that the numbers you're reporting are within those limits. Quality control then is the other side of the same coin, because that's what happens at the lab level. You have specific control limits that you are requiring every analytical result to fit within. And you determine that by analyzing control samples where you know what the numbers are, and you measure those samples, and if they're outside of a given set of parameters, outside their limits, then your system is said to be out of control, and you need to start over, recalibrate everything until you get things within those control limits. Primarily because it's been going now, or will be going by the time you guys see this, for 40 years. And you want to be able to say that the data that was collected back in 1978 is comparable to the data we're collecting now. You want to be able to go back and say, plus or minus this, let's go through the 40 years and figure out what the maximum control limits were all through those 40 years, and then be able to apply that to the data today and apply that to the data from 40 years ago. That's what gives you the ability to make these long-term maps where you change, is it 3 years? I think they do the 3-year summary maps that show the changes, of course, the course of the network. You can do that because you know the system, the analysis was in control based on all of this extraneous data. So it tells you that the data you're using today was just as good as, if not better than, the data from 40 years ago. But because you have the control information, you can actually compare that data from 40 years ago to the data you have today.